Today's dynamic and uncertain security environment places new and challenging demands on the United States Navy. A growing array of maritime threats confronts the nation, and the Navy needs a system that can provide a persistent maritime intelligence, surveillance, and reconnaissance capability with worldwide access. Immense areas of both open ocean and littoral seas must be searched continuously. Threats hiding amidst innumerable large and small contacts need to be accurately identified and tracked, and vast amounts of surveillance data must be reduced to actionable information in near real time to deliver effective maritime domain awareness. The Navy needs a transformational set of capabilities to continue to meet their mission, and improvements in existing systems can only go so far. That's why the Navy is investing in the future, and one of the Navy's most significant investments is in Broad Area Maritime Surveillance, or BAMS. Northrop Grumman's BAMS unmanned aerial system stands ready to provide the Navy with unprecedented persistent maritime intelligence, surveillance, and reconnaissance, or ISR, capabilities. And Northrop Grumman's BAMS system will best complement the Navy's existing P-3 Orion fleet and the new Multi-Mission Maritime Aircraft, or P-8A, Poseidon program. Together they will work to meet all the Navy's highly demanding maritime ISR requirements. The Northrop Grumman BAMS system will also bring a fundamentally new element to the Navy's network-centric warfare architecture. The onboard communications suite will provide a scalable, net-ready, publish and subscribe system that will dynamically adapt to available bandwidth. Maritime data will be sent simultaneously to many fleet users via multiple communications pathways that are prioritized to best support operational demands. The Advanced Information Architecture, or Server in the Sky, will provide a fast, simple solution for all tactical users to access and share mission-critical data. Maritime tracks, imagery, and signals intelligence will be processed on board and relayed to shipboard, land-based, and airborne users via line-of-sight or satellite communications links in near real time. Commanders will receive continuously updated information on the numbers and types of vessels present within their designated search area. With the Northrop Grumman BAMS system orbiting far overhead like a dedicated low-orbit satellite, Navy commanders will have control of their own organic means of broadband data and communications. The Northrop Grumman BAMS system sets a new standard for autonomous unmanned aircraft performance and maritime ISR capability. The airborne portion of the system is carried aboard the new maritime RQ-4N unmanned aircraft, a modified version of the combat-proven Global Hawk that's unique to the United States Navy. The high-altitude maritime RQ-4N flies up to 60,000 feet, providing a continuous view of wide areas of both open oceans and littoral seas, and carries a sensor payload that's been optimized for the maritime environment. It flies far above the strong winds, severe weather, and commercial air traffic that limit other manned and unmanned surveillance aircraft. Flying at these higher altitudes allows the onboard sensors to detect targets at a greater range for earlier warning, and keeps the aircraft above the lethal altitude of most surface-to-air missiles. High-altitude flight also brings the advantage of higher speed, allowing rapid revisits of critical areas. Rapid revisits prevent threats from leaking through our defenses undetected, increase the detection of high-speed mobile targets, and ensure the optimal engagement of time-sensitive targets. Although capable of unmatched high-altitude operation, at any time during its mission the maritime RQ-4N can rapidly descend to 1,000 feet and below to positively identify and relay images of any maritime target, and can quickly climb back to 60,000 feet to regain the overall common operating picture for the Maritime Force Commander. Northrop Grumman's BAMS system's 360-degree airborne sensors provide unsurpassed spectral persistence through the multifunction active sensor radar, high-resolution electro-optical infrared sensor EOIR with multi-mode full-motion color video common to MMA, and electronic support measures with specific emitter ID signals collection capability in any weather, day or night. The new 360-degree multifunction active sensor radar will provide the United States Navy with a state-of-the-art radar that will find and identify hundreds of targets at longer ranges much more quickly and accurately, with better reliability than currently deployed airborne radar systems. Northrop Grumman's RQ-4N also has an internal payload of 3,000 pounds, the ability to carry an additional 2,400 pounds externally, and a new generator that delivers 25 kVA of power, plus additional growth margin that's available today. By combining exceptional sensor performance with high and low altitude flight, a 310-knot cruising airspeed, and greater than 36-hour endurance, the Northrop Grumman's BAM system provides unsurpassed global access, persistent surveillance, and mission flexibility at the greatest distances from its operating bases. The multiple cross-cued sensors carried aboard the maritime RQ-4N can survey much broader areas at a fraction of the cost of any other manned or unmanned alternative, allowing the Navy to achieve global maritime coverage from only 5 main operating bases, and thereby reducing the Navy's dependence on foreign basing. Linked by the Northrop Grumman BAM system, dispersed network naval forces will project unprecedented offensive power and achieve defensive assurance and operational independence, as envisioned in the Navy's transformational Sea Power 21 concepts. Northrop Grumman's maritime RQ-4N delivers unmatched capabilities to support naval transformation. But most importantly, this system is more than a concept. It's combat tested, combat proven, and combat ready.